going to go through Section 8, Unit 4, just real quick on the slides, and then we'll be out into the shop. And this week we need to finish up all of this module. So that means the finishing up of your 8 parts for your rocket. And then there's 2 metric parts. We'll spend one day circled back in here talking about the metric micrometer, the regular inch micrometer and the metric micrometer, and we'll get those inch parts done. When you make those metric parts on the CNC lathe, I don't want you to try to, those programs are written in metric, so I don't want you to try to run those programs as though they are inch parts, trying to do some conversions and stuff. We'll switch the machine to metric. We'll run everything in metric. Then after we're done, we'll switch it back. So machine actually most likely runs in metric anyways. The inch that you see is just a conversion overlay that goes over the top of it. All right, so we'll look at Section 8, Unit 4, CNC setup or turning, setup and operation. If it were me, I would have my computer out. I would be going through the quiz questions right along with me. And then that way we can just kill 2 birds with 1 stone. There's zero reason why you don't get 100% on these things. Only reason that you don't get 100% is if you're not doing the work and trying. You want to go get a computer? Okay. Okay, so you have your MCU or your machine control unit, which is your control panel. And it doesn't really matter. This is a FANUC, but it doesn't really matter if it's the Haas, if it's FANUC, if it's a Mori. Everything is kind of laid out in groupings or patterns. You might go to a shop after leaving here that may have Haas machines, may not have Haas machines. They may have a Haas machine from 20 years ago. The layout's similar, but it's not exactly the same. And again, we're not trying to teach you how to memorize motions. I mean, some of those times, sometimes we are, but really we want you to be able to kind of figure out the layout of the machines. And so you as the operator have the ability to control overrides, single block, optional stop, turn the coolant on, off, slide hold. You know, you do a lot of things from the control here. You can create programs, you can edit programs, you can do just about whatever you want, as long as that's the approved allowances for you. So if they just want you to run parts, they might lock it out so that you can only run parts and you can't do any of the programming or editing on there. Especially on a FANUC or a Mori, you have what's called soft keys. Soft keys are the keys that they're kind of they're the key that changes depending on the screen that you're on. So these keys don't actually have any real designation to them, but they'll change depending on what screen you're on here. Here you're on offsets. So it changes to the offsets. If you were on program, they would then change to something else as they went along. So you have your jog handle or your jog buttons that you can jog around everywhere, anywhere you want. If you notice on the Haas, if you hold rapid and the direction, it will automatically move. So if you've been cranking the wheel and you don't want to crank the wheel, if you just hold rapid and the arrow button of the direction that you want to go, it'll move there by itself. So, let's see. Work holding. For us, depending on the machine that you're on, some are hydraulic chucks, some are regular chucks like this. And whether it's a manual chuck or it's a hydraulic chuck, you need to be able to pay attention to the amount of chucking pressure that you're using. Right now, we're using a lot of 1-inch aluminum. You can clamp down on about as tight as you want. When you start to use some parts that are round or that have a hole in them, if you put 600 pounds of clamping pressure on it, all you're going to do is make that thing a big triangle, because it's going to push that thing down. So you want to make sure you're using the appropriate amount of pressure. Once we go over to the hydraulic chucks, then we'll see a lot more stuff like that where we're setting the chuck pressure. Like right now, I'm using some 2.5-inch stock, solid. I got about 200 pounds of pressure on it. Now, if I was using some, let's say 2.5-inch round stock, but it only had like 100 thousandths wall, I would be under 100 on that, because I would have egg-shaped that. And even though it would have cut the whole round, whenever I parted it off or whatever, it probably would have sprung out or had some other kind of problem, or the bore would have been right and the outside would have been wrong. Something, you would probably concentricity problems, roundness problems, all kinds of problems along the way. Depending on the type of machine, really the way that the collet system works, or even just the clamping system works, is there's a pullback when it tightens the chuck, and you'll see that especially on the hydraulic. They just have a little cylinder back here, and it expands, which draws this back. So when you're holding a part and you're clamping it especially into one of our hydraulic chucks, grab a hold of it so that it doesn't slide back. So if you've got to have it held out, say 2.5 inches out in front of the chuck, and you just go ahead and hit clamp or hit the pedal to clamp, and it clamps, but then you notice that it doesn't do a face cut, it's because it pulled it back. So a lot of times you want to hold some pressure up against there. If you're using like a parts pusher, bar feeder, or something like that, keep the clamp pressure up, or keep the pusher rod pressure up against that as it clamps, and then pull it away afterwards. That way it stays in its right spot. There's chuck pressure. Also have tailstock pressure on there, depending on if you need it or not. This is, I think, a great idea. You have your chuck jaws that's on a hydraulic chuck. You have your cutting tool. You have an 1/8 inch minimum clearance. That is awesome if you can. But if you're trying to follow the rule of 2.5 times the diameter for a length stick out, then sometimes you can't do that. Let's just say you've got 1 inch diameter, 1 inch diameter, you can stick out, thank you, 2.5 inches. And sometimes you can have this 1/8 inch, but even a thou's clearance, right? So it's okay to go all the way up to the jaws if that's what you need to do. But you need to think about, even though you turn this all the way up against there, depending on your parting tool, your part off blade may not be at the very front edge of your cutting or of your tool. Like our parting blades, they set back just slightly from where that is, and so that's a problem. Now, regular grooving tool, not a problem because the insert is on the front edge of it. But since our adjustable blades on our parting tools, if you wanted to take that parting blade all the way up to the front of the chuck, you would hit the body of the chuck before you hit the rest of the chuck. So you want to make sure that's not an issue. So really, instead of saying a minimum 1/8 inch clearance, look at the area around that you're working in to make sure that you have clearance. Okay, that's what we're looking for. You shouldn't hit the chuck. Your work coordinate systems, for us, really, and I think for probably 90% of CNC turning, your Z0 is at the front of the front face of your part. Sometimes it could be at the chuck. If it's at the chuck, so anybody want to take a guess on how you know if it's set to the front of the chuck or the front of the part? 10,000 non-credit bonus points if you know. Think about it. I'll give you a second to think about it.
What was the question again?
Oh my gosh, what was the question again? Man, you guys should be good like Brian. So how would you know if your Z0, so you're the operator, you come up to a part, how do you know if Z0 is set to the front of the chuck or front of the part?
You go into your offsets and it'll probably tell you where it's set at and where it's not.
If what's negative?
Oh, well, no, it won't be negative because it's 0.
I don't know.
You can see if your 0's at the end of the stock, if it goes positive, if you pass it. That's one, but that's like, there's probably like a million other ways to do it.
Yeah, there's a couple primary ways that you can tell quickly. You else want to take a guess?
It's probably super simple. It just
In your program, if the front of your part's 0, all your Z's will be negative.
okay, it's something about negative, kind of sort of.
If the front of the chuck, all your Z's are positive. So when you look at the program and it's going to X of 1 inch, for the diameter, Z -3 inches, you know it's the front of the part. If it's going to Z0 or Z 1 inch, you know it's the front of the chuck. Okay. Two real quick ways to know that. Your work offsets for the lathes, our work offsets are always 0 unless we're doing some type of modification, some type of work shift or something like that. At this time, we're not. So just remember that all your work offsets should always be 0. That's 54,259. This would be a work shift. I'm not going to go through work shifting right now. This again, slant bed, and the setup for the slant bed lathe is slightly different. There are a couple different ways to set 0. My preferred way is that whether it's an OD tool, ID tool, grooving tool, parting tool, threading tool, it's always off the front of the part while it's spinning. If you're using, so they've got a 10,000 shim in there. If you bring it up, the spindle's not spinning, bring your tool up to the front of the part, put a 10,000 shim in there, you always have to add or subtract 10,000s to your tool every single time. You know what I'm saying? So I bring it up, I touch it to it, I do part 0 set for Z, then I have to do -10 to move it in another 10. Otherwise, it's not going to touch the front of my part. So in doing that, I think that brings in error lots of times. And then if you're doing it on the outside diameter, so let's just say I don't have my spindle running. I bring my tool up to it. So let's pretend this is a turning tool. I bring my tool up to it. If I got my shim in between here, got my 10,000 shim, I bring it up here. I could just barely drag it through it, and I hit X diameter measure at 1 inch. Well, it's not really at 1 inch, is it? And so let's just say my 10,000 shim is there. I take it out, and then I subtract 10,000ths, but I don't subtract 10,000ths. I have to subtract 20,000ths because it's diameter, right? So you end up having to try to remember a whole bunch of other things in doing it. Find it better if you just take the cut across it, leave it where it's at, drag it back, measure your diameter, 1 inch, X diameter measure. It's just going to be a lot less steps to do. Here's one of the things I think that you guys are most fond of is indicating a drill or a boring bar.
And I love indicating.
This is a coax indicator, so they've got it spun in kind of a different direction. So they're chucked on the coax indicator. They've got it, same thing though. The only difference between the coax indicator is that dial doesn't spin. Like it doesn't get to the point where you can't see it and then you can see it.
Like, it goes up and down.
Yeah, so even as you spin the chuck, this part's gonna spin, the dial stays in the same place. So like on a coax indicator, I think I have one in my box. You can, like when it's stationary, you can spin the dial around it so that when you are spinning the whole chuck, the dial stays in position. So, which is great because you can see it the entire time. So the same thing if you're over on the mill and you want to indicate a bore, you don't have to try to look around it or do other things so that you can see it. And oftentimes I will break out the coax indicator for students to use. I generally tell them to set the indicator in a spot so that the face can be seen from all sides. That way you don't have to do that. Because like my coax indicator, I think I paid $500 for it. So it's just another thing you have to have. If you're only going to work like that, when really, I mean, I've got 5 different kinds of indicators in my box. But if you can just get really good with the one, you just have to have the one. And so, and now for me, I have special indicators for special things. But if you don't need that, then you don't need it. You don't want to, the coax indicator doesn't work for everything. Coax indicator isn't really awesome for squaring vise. I mean, you can do it, but it's not optimal for squaring a vise. So if you're using this, this is great, and I think I have mine with me, and I'll bring it out. If I don't, I'll bring it tomorrow so you can see it. It's a little hard to get if you can't see it. But what happens is this is just loose on there. It spins, and it's got a drive pin that you stick out, but you have to hook that drive pin somewhere so it can catch it, so that the face doesn't spin around. It becomes complicated in a different direction. All right, tool tips. Tool tips are not going to make much difference at all for us on the lathes that we're on. When we move to the slant beds, we'll see tool tips start to get just a little bit more important, actually a lot more important, especially because it's got a touch probe on it. So if you had to take a guess, pretty well leads to it here. If you had to take a guess, which tool tip are we typically using on our lathes in orientation? Okay, so chuck's here, right? Part's here. Is our tool in the orientation of this, where the insert's away from it? No. Is it straight on to where the tip is like here's our stock? Is the tip right on the end of it? No. Is it coming at it from this angle? It's not coming at it from this angle either, right? So here we have 3. It's coming at it from this angle, right? So if you rotate it this way, you can face and turn with it. Okay, so 3 is primarily your OD turning and facing. And then you have 2 for facing and boring. So it's just it's this rotated this way. Okay, so you'll want to know that, especially on the probe, and I'll set up one of the probes over on the slant beds. It's got that swing arm that comes out. It's got a square on the end of it. And that tool, it just needs to know whenever I'm probing, am I probing like this and like this? Or am I probing like this and like this? Okay, so 3 would say, okay, well, we're on the outside. That means we're going to probe this and this. Inside means we're going to probe this and this. So it's the orientation of the tool. The Haas control, especially the new Haas control, literally shows a tool faced in that direction. Like, are you doing this? And it really leads you to it. And so it's hard to get it messed up. Now, when we move over to the mills, there's very similar sequences like this in probing. And did you guys have probing on your machines? You didn't. So same scenario. So if you want to bring one of the Renishaw probes in, and instead of edge find, you want to probe the outside of this, it shows you a picture. Do you want to probe this and this and this and this? Do you want to probe this and this? Do you want to probe this? Like the pictures basically show you the system. But just like anything, it's interpretation. And sometimes it's a visual picture of what it is, like a photo. A lot of times it's like a drawn picture. And the more you can kind of start to get the idea of the skew to the relationship of it, it's going to make more sense. So it's just like once you know how to read the manual makes way more sense. But the first time that you open up the manual, you're like, I have no clue what this says. But when you can relate it to something, then you're like, oh, okay, that makes sense. So probing even on the mill takes a little bit of time just to get going. But once you kind of get the idea of those things, then you've got it from there. Programs can be put into the CNC machine, whether mill or lathe, a couple of different ways. You can just type it out right on the control. Okay, just write out every single program number 1, this, and this. What? Oh yeah, that's how we used to write them all the time. So we used to literally write them on a notepad,
And then walk over to
the machine and type it. Like we had built little things to hold your arms up. You would be there for like you might be there. Like I'm not kidding you. I wish I still had them. I had them here for years. I have 30-page programs of just 12, maybe 10 maybe font, just typed out programs that before we had a network, our backup was to print them out and keep them in a giant file folder. And if we had a problem, if we lost all of our programs, we hand typed them all back in. Yeah. It was death. It was. I mean, you were like, it's
Shortage and everybody.
exactly.
It was like the.
All right,
manual
guys,
mill
we're
trying
gonna
to
need everybody here.
twirl that thing all day long.
Oh my gosh, it was terrible. So one day, I had a guy call me. It was like 3 o'clock in the morning, working overnights, and he goes, "Hey, I got a problem." I'm like, "You must, because it's 3 o'clock in the morning." And he goes, "You know the button delete all?"
Oh.
I go. He goes, "I thought it meant delete all that line." It doesn't. I said, "I know it doesn't." He's like, "So I deleted all the programs in the machine." So it was a horizontal machine like that. I mean, it machined 15 parts in different positions. So like you would do a part like this. You would take it and it would go here. Then the next time it'd run, it'd go down. And the next time it'd go, and it kind of went like in an S shape to get all sides of the part. You know, you were machining like 8 sides of the part. That along with 50 other programs. And he's like, "So I deleted all of them." And I was like, "Okay, that's a problem." He's like, "I know, because I didn't want to call you." And I go, "Well," I said, "avoiding it isn't going to solve the problem." But by that time, we had a network system that we could back them all up on. Came in that morning. I said, "Hey, let me get ready." I said, "I'll be there in an hour," and got there. And then we loaded them all up before the owners came in, and nobody ever even knew it. So I just told you guys not to kill you. But so yeah, no one even knew the difference on it. We went just fine. But had that happened like 4 or 5 years before that, one of our owners was really, really smart. Is really, really smart. And he foresaw, he saw all those things before they ever happened. He's like, the minute that networking was an option, we were networking stuff. And I mean, like we weren't doing it like the way we do it now. We were hardwiring things into everything, and like we would come in on a Saturday and we'd run Cat5 cable everywhere to all the machines. I mean, this is before there were network switches. We had switch boxes that like you wanted to go to machine 28. Oh, nope, now I go to 10 over here, and then 10 more over here, that makes 20, and then 8 more over here, that makes 28. It was like you were doing, like, you're on a stagecoach, man. I mean, it was just like the oldest thing in the world. But that was like the newest technology at that point. We knew no other way to do it. Now, like, it's Wi-Fi. You know, like all of our new machines have a little Wi-Fi antenna on them. I mean, I can watch you machine from my phone or at home now.
What?
On all of our machines that have a little antenna on them, I can just log into them and watch from the inside of the machine. If it has a Wi-Fi camera, I can watch you run it, or I can actually see what you're doing on the control. So, which
You should definitely do that, like when you're out. And
Right? No way.
Scare me. Email us or something.
Yeah, yeah. Send
I
a
saw
message
you on that
send a message on the screen.
Yeah.
Dude, don't do that. You know.
Getting real close to that chuck
I
there.
don't know if the technology is quite there, but it's close.
Well, technology's there, you just don't got it on that machine.
Yeah, well, I don't know that those do that. Yeah, but yeah,
Your tool numbers start changing and then
right.
Justin was here.
Yeah, exactly. Yeah. Why did all my tool numbers change from 12 to 22?
Change all your offsets.
So you can upload a program from a PC or some type of storage. And now all of our machines, I think, have 1 gig of RAM on them or hard drive space on them. But what happens if a program's bigger than that? Like, what's that? So sometimes your program's going to be in a spot where it won't run like that. And so we have a drip feed where you can hook a laptop up to it. And it'll handshake back and forth. And so handshaking just means that it can take this many bytes of information. Once it's expelled those bytes, then it jumps into the next section. And so it just keeps shuttling it back and forth until the program's totally done. And so let's just say you've got a smaller machine.
That's used in a lot of different things too.
Yeah, exactly.
Pretty
Yeah.
cool.
And so like if you have a program, let's just say you're trying to machine the outs, like you know when they do models of cars, like full-size models, that's a huge program. And so I don't know what size, memory capacity something like that is, but most likely they're drip feeding it from something like that when you're doing a full-size
So if the
car.
hard drives
Full-size
aren't
car-
big enough,
car-
why don't they
car-
just make bigger hard drives?
Well, I think it depends on the programs that you've got. So we've never had a drip feed
Terabyte or
problem.
something.
Yeah, but in doing that, so let's just say that happens once a year that you might need something like that. Well, if it costs you $10,000 extra to have that on your machine, you can't have every option. I mean, you can, but realistically and financially, you don't want to have every single option. No one buys a $10,000 option that they might use once a year, when they know there's an alternative to drip feed or doing something different.
You know, my dad just spent another $1,000 on the 3D fish finder.
So $1,000
But I'm just saying,
versus 10,000, there's an extra zero on that one that matters.
It's a big difference on fish finder. I mean,
Sure. Yeah, absolutely.
$1,000 on the fish finder, then you spend another 1,000 just to get that thing.
Yeah, absolutely. But the thing about like buying a machine, I mean, it's easy to be, even on a very simple basic machine, it's easy to be over $100,000 in a split second. So,
Trash can machines. Put one in my room.
oh, yeah, yeah,
That'd be so cool.
that'd be cool. They're underwhelming is the problem. Is those little machines like that. Even like the Tormachs, I don't know if you guys have seen the Tormach mills out there. They're good little machines, but they do not have much torque. So you end up stopping the spindle all the time because you're just frustrated. You know, you're like, it takes the cut.
Have like,
Doesn't have enough sack to it to do what it needs to. So our Intellitex, that's exactly how they are. If you try to machine steel on our Intellitek mills, you will want to pick that thing up and throw it out the window.
Stop all the time?
Well, it comes across and it can't take the cut. I mean, for a mill cut on one of those Intellitek machines, if you're taking 10 thousandths, you're taking a big cut.
ooh, really?
Which means, like, if you're gonna mill this in 10 thousandth increments,
Even all day.
yeah, especially as steel. Now, in aluminum, you can get a little bit more out of it, you know. But if you'll notice,
I feel like they're used for like making really small parts though,
I feel like they're used by schools.
like just to teach people, like get people on. Are you guys gonna put some in that room over there? Put some in
That room's done, I thought.
Well, I mean, like we'll have some, they already have the small Tormach mills that we saw over there, the little ones on that table.
Yeah.
Yeah. That's all that they're gonna have in there. And they'll probably cut like acrylics and plastics and wood and stuff like that. They will not be machining aluminum and steel. Yeah.
I could see one of those things struggling on steel a lot.
Oh, totally.
Like,
Yeah.
I struggle on
But-
the regular lathe, so.
But just think, if your business is to cut plastic, acrylics, wood, foam, then that makes sense. You don't need a big machine like this to do that. It's about knowing what you need to use.
It'd be cool to have in like every egg shop or just to have a CNC machine. I think it'd be cool.
Yeah, but again, the problem with that is somebody says, let's just try to keep it in the ag shop. So somebody comes in, you got a little machine like that. Somebody comes in and says, hey man, can you drill these 5 holes for me? No. Well, you got a CNC machine. Yeah. If you need a little widget made out of plastic, I'm your man. But if you need something that really serves a purpose, let's go to the drill press and do it. You know, so they end up being kind of pointless.
Yeah, they have, a lot of ag shops have drill presses and stuff in
Sure.
there, just don't have CNC, nobody.
Yeah. But the need isn't there.
Yeah, it isn't there
Yep.
yet.
Yep.
Yet.
So, you can come from a PC, or, so here we have drip feed, and then, you can bring it in from a CAM system as well. So here you have, drip feeding, and then you also have programs being loaded in from a PC, direct from the PC as a program. So some machines, like especially the Tormachs, they're actually, the PC is the control for the machine. So instead of having like a control panel like that, it literally just has a PC that sits next to it and it plugs into the machine. So you're really operating off of a PC. So just a couple different ways. This one should be pretty similar to you or for you. This is the Haas control. It allows you to have some graphics. Remember, graphics is not a full 3D image of the part, but to run a part without going through graphics is to like drive blind, right? You should never ever start the program up without running graphics. A couple different ways you get to graphics. In memory, you can hit settings graphics and cycle start. Easiest way is in edit, hit cycle start, and it'll automatically go to graphics. Well, in edit. So I'm in the edit function, I hit cycle start, and it'll automatically kick up the graphics screen. Otherwise, you can do it in memory, setting graphic and then cycle start, and then it'll do it.
What's our first project on the mill?
A mill part. Yeah. Let's get these done first.
I feel like he's
So
gonna.
we've got to finish our 8 rocket parts. We've got 2 metric parts, and then we've got 47 other lathe parts that need to be done this week. That's not true. You got your 8 rocket parts, and then 2 metric parts, and then we're on the mills. Okay, so we're almost there. So the cool thing about the Haas simulator is it's the exact same simulator as Control. Fanics are the same way. But this gives you the ability to kind of see what's happening here on the Control within, like, you know, it's a 2D representation of what's happening there. So always use it. All right, I think that's it on that. Okay, I'm gonna pop up the quiz. Let's see what we can come up with.
Anybody else in pre-algebra? Not pre-algebra, tech math? Did you do that homework 5? The 5 homework? Because it like would not let me turn it in. Yeah, I know, but I did that and then it says like, it doesn't even give me an option to submit it. It just says submissions and then it sends me to my files. I don't have files on my phone, like I don't, it's not like letting me use a picture with my camera or anything. Usually it just says hit submit and then camera.
Quiz are you going?
3.
Which quiz are we reviewing?
Section 8, Unit 4, CNC turning setup and operation.
Did you guys do that survey to win that $50 gift card?
Most people don't. When was it?
I didn't do today. Better yesterday.
Hardly anybody ever does. Anybody do a survey?
Is it on the community college website?
Yeah.
I'll do it.
No. There's stuff like that on there all the time.
You just got, and they'll email you about it too. Module.
What? Section 8.
Section
I
8.
think 4.
4? Trying to look.
CNC turning, setup, and operation.
Yeah, I see it's 4. It's in module 2.
I think this is our last quiz for CNC turning.
All right, I'm gonna take the quiz. Yeah, mills are gonna be fun. I didn't get much time to mess with, we didn't get much time to mess with the other mills, so I'm excited.
Yeah, that class actually, manual milling,
I do have a question.
intro to machining, manual machining, really barely spends any time on the mill because when you start 102, it starts on the mill.
That's what Jacob said. He said, you're gonna, trust me, you're gonna have plenty of time to use it.
It's mostly mill. What was your question?
That's about it. I'm ready to run that mill on the CNC mill. It's exciting.
So you're either gonna find yourself liking one or the other more.
I like lathes a lot, but I don't have enough time on mill yet to like it. We'll see.
What do you guys like better?
I like lathes because they're easier.
I don't, I've done enough programming for this.
Program for lathes.
I've done way more than you'll program.
Yeah.
Programming is cake.
I like round curvy parts. That's why I like the lathe better. But I guess it just depends. Like,
Make a Turner square, that'd be cool.
yeah,
How hard is that to make?
they had
It seems like there's a lot of tolerance you have to keep.
just one, it's like, in every program or every operation, it's just one step, then the other step, then the other step, and the other step. It's just how many more steps you want to add to it. I don't think that any of them are necessarily harder than another one. It's really kind of just going, like having the stamina to get through all of the pieces of it, you know, because you're like, okay, let's go. And then there's like, within 3 steps, everybody's like, let's just call it good here, you know? And so I'm like, well, there's really like 19 more steps to do. And so it's just about how many steps that you want to do. All right. Cartesian coordinate system that identifies the location of the origin of the workpiece.
I only know what one of those means.
Isn't that WCS?
Yeah, MDI. It's the only one I know.
MDI, manual data input. Let's grab a book. Section 8. Unit 4. What's that? Yeah. Yeah.
Section 8, Unit 4,
Section 8, Unit 4.
636.
Isn't that WCS though?
Work coordinate system. I think work coordinate system would probably fit. I think MDI definitely will not fit. I think DNC definitely does not fit. So there's 2 on there that does not fit.
Machine coordinate system, isn't that like machine home?
Yeah, so your machine's coordinate system is your machine's coordinate system. So on a mill, on a lathe too, so generally on a lathe, we would call that G28, the machine coordinate system. When we say go to G28, it goes back in X and Z on our 2-axis. That's the machine's coordinate system, and that's where everything is measured from that point. Your tools, when you come up with those numbers that are like minus 25, whatever, it's from the machine's home position. Okay. So your work coordinate system is when you bring that up to the front of the part, and you say this is now 0. It's kind of the floating coordinate system. So then now, instead of being negative 26 inches, because it is negative 26 inches, it's negative 1 inch, because from the work coordinate system, that's where everything is going back from.
So, work coordinate system is the Cartesian coordinate system that identifies the location of the origin on the workpiece.
So the kind of the key word to that is, or the tipping factor on that is the workpiece. So it's not to the machine, it's to the workpiece.
So WCS.
When using TNRC, the tool tip blank orientation must also be entered in geometry, in the geometry offset page. So that's the one that we looked at about the orientation of the tool tip and where it was sitting at as far as 1, 2, 3, 4, 5, 6, 7, 8, 9.
Found it.
So what do you think it is?
I found the page for it though.
We're going to rely on you.
That's horrible. I should never.
Okay, so when using tool nose radius compensation, the tool tip coordinate, you think it's coordinate?
In the book.
Okay. Could it be axis? So it would be tough for it to be axis. Dimension, it's not a dimension. And then quadrant. So the hard thing about quadrant is that in quadrant, there's not an unlimited amount of quadrants, right? So you really got to look at, you don't look at axis, you don't look at dimension, you don't look at quadrant, and you said you think that it is coordinate. I think coordinate makes sense.
So you decided coordinates was correct?
Was that, I think the coordinate fits best. Because the other ones just don't quite work. Axis, you only have 2 axes. That doesn't work for your 9 basic options for doing that. The dimension, it's not asking you for a number or a numerical dimension at all. Your quadrant, you have 9 different quadrants basically to work from. I don't know that that really quite fits with the word quadrant. So coordinate though could work. I think quadrant could work if you said more of, maybe you said it by orientation. I think orientation might even be a better word for it to use. Most machines are equipped with a blank control to slow the rapid motion while the program is running or vary the jogging rate. What's that?
Rapid override.
Rapid override. Direct override, dry run, feed rate override, rapid override. Dry run is when you run the program above the part, no Z movements. Okay, so it would, like on a mill, it's going to run the entire part and never go down to the part. So it'll stay up above the part. And it'll run at full strength, full power, but it's never going to cut a piece on it. Okay, so it's definitely not dry run. Okay, so feed rate override slows its feed rate. Mm-hmm. Yeah, even yeah, none of those are going to slow this. Yeah, none of those are going to slow the spindle down. I mean, you're going to have your separate spindle override for that one. So the question asks to control the rapid motion. So it's got to be the rapid override, right? It doesn't make sense that it'd be the feed rate override. Now, you could have a machine that both rapid and feed were controlled by the same knob. In here, that's not what we're talking about, and out there, that's not what we have. Like, there are a lot of companies that have produced CNC machines out there in the world. Some are really grand and amazing. Some of them, like, they practically have a startup crank on the side, you know. So, I mean, there's been some small startup CNC companies, like Tree is one of those. The Tree Machine Company, I don't even think they're in business anymore. They even created their own G-code system, which that's kind of like building a car that only goes on the sidewalks.
Why
You know
would
what I mean?
somebody make their own G? Why would they?
I don't know.
That is the dumbest thing I've ever heard. It's like, here's.
I was like, I feel like it took you more work to do that.
Here's a machine that it's never going to be the same anywhere else.
Right.
We're just going to learn how to run and write code for this
Yeah.
one machine.
Now, a conversational control is similar to that, in my opinion, because like you have to know the conversation of that machine. You know, they're not always the same. So Hercos and some of those other ones, they're pretty easy to get the hang of, though.
Like some plated ones or what?
Conversation code is great until you want to do a thing like this, where, like, let's just say I've got a drilling cycle on my conversation code. I tell it what drill I want to use and how far I want to go back, and that's awesome. But now, on the back side of that, I want to bore the hole backwards because this insert's bigger, and I want to drill it in, and I want to shift it over and drag it back, but there's no conversation for that. And so what do? You know, I have to come up with a conversation or a template to try to manipulate that out. You know, and so like we had a conversation control on our alpha lathes that it didn't really have a conversation for a casting. And so the casting was shaped like this, but it could only machine like this. So what we would see, you'd air cut for like 3 inches, you know, just nonstop. So it'd be like quack, 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 quack. And you were like, dude, all this air cut is just driving me crazy. So we would make a separate program that came down here and faced it, and then came over here and turned it in order to get that. So like you had to always be manipulating it. Then when you go to your next person, you go, hey man, so on this program, I know it looks like that and it's running like that, but here's how this happens. And if you need to change it, you've got to do this. You got to stand on one leg here. You got to plug this in here, hold the, whatever. And you were like, I'm just going to hope it doesn't have a problem. And then inevitably, the minute you walk out the door, it has a problem. So, but if you're doing straightforward conversational programs that fit the conversational lifestyle, that's great. You don't even literally have to know any G code at all. It asks you the questions. How fast do you want to turn the spindle on? And it writes the code, M3, S 13,000 RPM. It does those things for you. So like it does have a great benefit, in some of those, in the right applications. The distance from the origin of the MCS to the origin of the WCS is called the work offset. So our machine coordinate system to my work coordinate system, right? That's my work offset. That's why that number is -8 inches or it's -26 inches. It's from the machine to the work. Question 5. Blank allows verification of the paths of the tool or of the paths the tool will take by watching a simulated computer model cut the part on a display screen. Graphics. Yeah, graphic simulation. And remember, you will be underwhelmed by all of the graphic simulation. No time will you go there and be like, this is awesome. If anything, you'll be like, am I playing Tron? Like, you guys don't even know Tron. But yeah, you know what it is.
I'm at least old enough for that.
Yeah, what?
I'm at least old enough to know all the video games.
Yeah.
Oh, yeah.
Yeah.
Got it.
Yeah.
That's my
So,
generation.
Tron movie actually came out before the video game. It was like in 1985. So, none of y'all was born.
I was born in '88, so don't.
At 3, you weren't watching the Tron movie or playing the video game. Yeah. But, I mean, I'm not saying you couldn't have played it. I'm just saying. And then, honestly, the new Tron movie that came out is actually on my top 10 list
Really?
of best movies ever. Tron?
What do you think about the difference between Top Gun and Top Gun and Maverick?
Then what?
Top Gun and Top Gun and Maverick, which one's better? Top Gun Maverick's better.
I don't know.
It's a tough one, but I think it is better. The new
Yeah.
one's better.
Star Wars Episode 3 isn't on that list.
Star Wars is
Talk
not
to
on my
me.
So
list.
the Star Wars family is on that
Not even
list.
on that.
Man, yeah.
It's not on my list. I hate Star Wars. I hate
Oh,
Star Trek.
man.
Might as well leave now. All right.
I love Star Wars, man.
Yep. Okay. The blank knob allows the programmed feed rate to be decreased, increased, or even stopped.
Feed rate override knob? It's a thing.
So ours isn't a knob, but it's a button, or it's buttons, but yes. The blank is used for the machine's own reference purposes, and it helps it keep track of how far each axis can be moved before it runs out of travel.
MCS.
Yes, I think MCS fits that best. MDI, manual data input, doesn't really work. Work coordinate system, machine coordinate system, doesn't really work, does really work. Oh my gosh. Okay, 8. How many questions are there? 10. Get them all there. Once tool measurements have been determined, those tool offset measurements are stored in the machine's blank offset page. Think about on the control what you see when you're looking at that page.
Where?
No, so you're on that's the page, but where only plays into when the tool started to wear.
The work offset?
It is the work offset, but what page is that? It has to do with what? Does it have to do with, it doesn't, so we said it doesn't have anything to do with the wear. It doesn't have anything to do with the run.
Geometry, isn't it?
would say it's geometry.
No.
I do think so. I think work,
I like work, but if you like the geometry better, that's fine.
I think work is a close second, but the work has to do with me setting where the work piece is. It doesn't have anything to do with my tool measurements. Those are in, and I think if you look at the top of the screen, it says geometry page. See here it says length geometry, diameter geometry, right there on that page. Okay.
We had the computer sitting right there.
Yeah, and sometimes it'll be beneficial to just go grab a simulator. We've got so many simulators.
Yeah.
And you can just, wow, why are you ahead of me, man?
Are you just flexing your simulators now?
I'm flexing, yeah,
You
flexing
should
my
see Ed's
simulators.
room. You should see Ed's room.
You should see the one that works at Clinton.
Yeah,
That works. There's like,
Yeah, it's got chips on the buttons and everything, so you can just have yourself.
and all their simulators are mine. It hurts my heart to know that they've been treated like that. Yeah,
They've been treated like a redheaded stepchild. They get the crap knocked out.
I sent 3 of them over there, I think that's what's over there. They're probably none of them, or just the one works, I guess.
Just the one works.
Blank mode provides a blank program screen for entering short programs or single program commands required for machine setup. MDI. Blank offsets may be used to compensate and adjust for wear as the tool is used during production. I just said the word.
Wear offsets.
Wear. Yeah. Oh, I did say tool, yes.
That's why I wanted to.
It's the adjustment for the wear as the tool. So as my tool wears down, I can either adjust it in the actual diameter geometry, or depending on what else I have set up. I can,
You got one of them wrong.
oh, what'd you get? Which one? It doesn't say.
Doesn't say.
You'll have to work that one out. Something's wrong somewhere. You can figure it out. You guys are smart.
I think it might be. I'm gonna take it again. I'm gonna look at it. We'll see.
Okay.
We just went through
Let me
them,
take
tested. What was wrong?
Alright. Cartesian coordinate system that identifies the location of the origin.
Okay, so that really finishes out Module 2. We're going to also finish out Module 3 before, let's just say our goal is to have Module 3 finished before Wednesday of this week. Okay, so we're really about there. We're on, so most of you guys have Haas CNC lathe operator done. You do lockout tag out on your own. It's 14 points, if you will. There's a video, and you just follow the video, answer the questions. Here's how I would do things like that. I would log in on my phone to Canvas. I would watch the video, have my computer open to the questions, answer the questions as they go.
Yeah, I tried that last night, it's not over too long to do that.
Some of
We're
what
out
are,
of time before the quiz is over.
oh, I see.
I tried to do that with the video as it was playing, go through it, and.
Run the video at 1.5 speed.
Yeah, you probably can run it a little faster.
And that's considered okay.
Module.
Yeah, I mean, it's a video. The only reason we can't do that is we can't make you go 2 screens. You know, we're not trying, no one's trying to like capture you in trying to get you to have a wrong answer. Like, really the answer to the question is confirming that particular thing in it. So, I mean, we used to just do it as like an explanation, you know, this is what lockout tagout is, you know, and then that's all we ever did. We just added some questions to it. Okay, so that'll finish out lockout tagout. CNC lathe operator should be done. 5, 6, 7, 8 should finish out your rocket. Then we're gonna go into metric micrometers, and it has a part, and then there's just, so I'll walk through metric micrometers with you, and then we'll do this metric part. At the same time, so what we'll probably do is bring in like parts 7, 8, and we'll make sure everybody's clear on the inch micrometer, and then we're gonna go to the metric micrometer. So we'll kind of spend this week looking at the micrometer, making sure that we're really solidified there. From that point, before the end of this week, we need to be in Module 4. that would be best case scenario, okay? That puts us into the mill, and then we should be able to go from there. So I'd like to have, I want the rest of the today to work with 117s and 118s. Tomorrow I'll work with 117s and 118s. Wednesday I'll bring you guys back, and we'll do those parts that we just talked about. And then that should set us up so that we can spend maybe some time Thursday, at least beginning to start to talk about the mill. You can always work ahead on things. That's totally fine to do. So like if you wanted to work ahead on this drill chart conversion quiz, that's totally fine. It is literally just taking that little drill chart that I've given you and putting the answer in.
I'm just gonna go straight back to Ed's room. Ed's one and just find my quiz, screenshot all of it, take your quiz.
Yeah, so I adjusted the quiz slightly.
Dang it.
Not my answers, but just the way that you answer them. Okay, so, yeah, I just adjusted it slightly.
Multiple choice.
It's not multiple.
Dang it. Oh, man, now I have to be like precise with it.
Okay. So, you'll see module 5, 6, 7, and 8 kind of grow as they go. So you really can only see probably module 5. 6, 7, and 8 will kind of expand as the mill parts come up. So right now, all we are is really to here. So you should only be able to see 5.
He's gonna put on there.
Yeah, you
he's
should.
gonna tell us that on that quiz or on that module, he's gonna make us change every single belt on every single mill. Seriously, what?
Untrue. Okay, questions? You guys are gonna work out that one question on your.
I'm pretty sure it was because I still got 36 out of 40 on it, and I changed my answer on one of them, and so on the drill.
Okay, work it out. You'll
Dang
get it.
it! I had it in my head.
You got all but one answer, so that shouldn't be that big of a deal. You can work out that one answer.
I think it's the drill. What's the one